Hello students, myself Sarama Malik Das, Assistant Professor of Gargi Memorial Institute of Technology. Yesterday I discussed about the chi-square test and today also I discuss about the chi-square test for independence of attributes. Okay. Now what is attribute? The character of statistical information which cannot be expressed in quantity but can be expressed in quality is called attribute. Okay. Now if I let A and B be two attributes and A is shown in the categories A1, A2 up to AN, whereas in B the categories are B1, B2 to Bn. Now, for example, let capital A is equals to family condition of students in engineering college. Okay, and B is equals to results in the final examination. Then A must be shown in the categories A1 is equals to poor class, A2 is equals to middle class and A3 is equals to rich class. Okay, these are the three categories of A, whereas B may be shown in the categories B1 is equals to fail, B2 is equals to first class, B3 is equals to second class and B4 is equals to fourth class. Third class. Okay. So, the frequency of each category obtained from a random sample are placed in a table containing in cross in cells. This is known as contingency table. Okay, the table is like that. There are three classes of family condition: poor, middle and rich. Okay, and four class in results: fail B1, first class B2, second class B3 and third class B4. Okay, so if the value is this type 5 4 3 6 4 3 10 8 2 12 11 4, so this is 33, this is 27 and this is 12. This is 12 13 20 27. Total value in both sides is equals to 72. So the contingency table of A and B, which is shown in this figure under the category of A1 B1, the frequency is 5. That means number of fail in the poor category, fails in the post class is equals to 5. Okay, similarly in the category of A2 B3, that is equals to 8. That means number of students in second class got second class for middle class is equals to 8. Okay, number of students got second class from the middle family condition is equals to 8. Clear? So now we test the chi-square distribution. Here, if the null hypothesis is taken as a 0, which is attributes A and B are independent. Okay, then it can be shown that chi-square is equals to summation of FO minus FE whole square by FE. This is a chi-square variate with R minus 1 into C minus 1 degrees of freedom, where R is equals to number of rows in the contingency table and C is equals to number of columns in the contingency table. If O is equals to observed frequency in contingency table, and if E is equals to expected frequency. Okay, so which is equals to row total of a category into column total of that category by total frequency. Okay, this is the formula of FE. So in the contingency table, if we find the expected frequency in the contingency table, the expected frequency FE of the category, say A to B3, A to B3 is A to B3, that means 20 into 27 by 72, 72. This is the expected frequency. Now if the computed value of chi-square lies between the CR, then H0 is rejected, otherwise it is accepted. Okay, so we know it. So now for the contingency table, for the 2 by 2 contingency table, okay, for 2 by 2 contingency table. Okay, now if the table be say it is alpha, beta, gamma, delta. Total, say it is C1, this is C2, R1, R2, and it is N. Okay, this is the 2 by 2 contingency table, where R1 is equals to alpha plus beta, R2 is equals to gamma plus delta, C1 is equals to alpha plus gamma, and C2 is equals to beta plus delta, whereas N is equals to C1 plus C2 or R1 plus R2. Okay, so chi-square becomes chi-square is equals to N into alpha delta minus beta gamma whole square by R1 into R2 into C1 into C2. Okay, with 2 minus 1 into 2 minus 1, that is 1 degree of freedom. Okay, but there is a correction, here is a correction is necessary since the degree of freedom becomes 1. This correction is known as Yeats correction. Okay, since the DOF is equals to 1, so there's need a correction, and it is called Yeats correction. Okay, so now we have to know that what is Yeats correction. Number 1, if alpha delta is greater than of beta gamma, then what happen? Then replace alpha and delta by alpha minus half and delta minus half, and beta and gamma by beta plus half and gamma plus half. Okay, and number 2 case, if alpha delta less than beta gamma, sorry, then replace alpha and delta by alpha plus half, delta plus half, and beta gamma by beta minus half and gamma minus half. Okay, so the Yeats correction for case 1, corrected chi-square is equals to n into alpha minus half delta minus half minus beta plus half into gamma plus half, this whole square by R1 R2 C1 C2. Okay, so that's equals to n into alpha delta minus half alpha minus half delta plus 1/4 minus beta gamma minus half beta minus half gamma minus 1/4 whole square by R1 R2 C1 C2. Clear? So this is equals to n into alpha delta minus beta gamma into, minus half of alpha plus beta plus gamma plus delta, this whole square by R1 R2 C1 C2. Okay, so from here this is n into alpha delta minus beta gamma minus half of this total value is called n in this whole square by R1 R2 C1 C2. This is for case 1 only. Okay, and for case 2, corrected chi-square is equals to, this will be same as, just it will change here, beta gamma minus alpha delta minus half of n whole square by R1 R2 C1 C2. Okay, so in both case the corrected chi-square is equals to n into modulus of alpha delta minus beta gamma minus half n whole square by R1 R2 C1 C2. Okay, So first example, so it is seen that a random sample of 500 students appeared in an entrance examination is classified as follow. Okay. Economic condition, there are three conditions: poor, middle, well-to-do. And total. In result there are two conditions. One is successful and another is unsuccessful. So successful candidate of poor category 160, middle category 30 and well-to-do 10. Unsuccessful of poor category 140, this is 120 and this is 40. Total is 200, this is 300 and here it is total 300, 150 and 50. Question is, test at 5% level whether result and economy condition are independent or not, and it is given chi-square 0.05 is equals to 5.99 for 2 degree of freedom. Okay, this is given. So we take here the null hypothesis. We take null hypothesis H0 is equals to the two attributes are independent. Okay, this is our null hypothesis. So the observed frequency FO are given in 2/3 contingency table. Okay. Okay, this is 160, 30, 10, 200, 140, 120, 40, 300. This is 300, 150 and 50, and total is 500. Okay, so the expected frequency of a category is equals to row total into column total by total frequency. Okay, so the expected frequency Fe of each category are as follows. Okay, so first one is result. This is economic class, sorry, economic condition. What is given here? Condition. Okay, under this condition there are three conditions. First is poor, then it is middle, and last is well to do. Total. Successful, unsuccessful. So here it is, first one is 200 into 300 by 500, that is equals to 120. Okay, this is 200 into 150 by 500, that is equals to 60, and this is 200 into 50 by 500, that is equals to 20. And unsuccessful, this is 300 into 300 by 500, that is equals to 180. 300 into 150 by 500, that is equals to 90. 300 into 50 by 500, that is equals to 30. So this total is 200, this is 300, and this total is 300, 150, 50, this is 500. Okay, so chi-square is equals to, from the formula, this is FO minus FE whole square by FE, summation of these. That is equals to, for the first one, this is 160 minus 120 whole square by 120, plus this is 30 minus 60 whole square by 60, plus then 10 minus 20 whole square by 20, plus 140 minus 180 whole square by 180, plus 120 minus 90 whole square by 90, plus 40 minus 30 whole square by 30. Okay, so this is equals to 55.56. Okay, this is our computed value. With degree of freedom r minus 1 into c minus 1, that is 2 minus 1 into 3 minus 1, that is equals to 2. Okay, and it is given that chi-square of 0.05, this is equals to 5.99. It is given. Okay, so integration from 5.99 to infinity, chi-square is equals to 0.05. That means CR is chi-square greater than 5.99 at 0.05 into 100, that is 5% level. Okay, so and our computed value, that is 5.56 is greater than 5.99. So this lies in critical region. So 80 is rejected as it is lying in the critical region at 5% level of significance. Okay, so we conclude that the result and economic condition of the students are not independent. They are associated. Okay, so next day we discuss about another example of this topic. Okay.